Hi, welcome to Think Human. I'm Chris, and in this video I want to talk about one of the most fascinating, mind-boggling and powerful objects in our known universe. What I'm talking about, of course, are black holes, and now to be absolutely correct, we couldn't really call black holes an object. A more correct way of saying it is more like a configuration or geometry of space-time. Black holes are black because nothing could escape them, not even light, the fastest thing in our known universe. So the smallest black holes have the mass of about 3 times the mass of our own sun. So if you have a bunch of stuff that weighs about 3 times the mass of our sun and we let it all collapse together, then this stuff would form a black hole. Another interesting fact, every single black hole in our universe is almost completely identical. Black holes are really simple things and they have only 3 properties, and these properties are mass, spin and electrical charge. So no matter if the black hole is made of stars or planets or asteroids or gas, if it's the same amount of mass, then the resulting black hole will be exactly the same with anything else, no matter what it's made of. So theoretically, every single object in our universe could be compressed down into a black hole. It's just a matter of compressing all the matter and mass in a given object down into a certain radius, and this radius is called the Schwarzschild radius. Our own sun's radius is 690,000 kilometers, and if we wanted to turn the sun into a black hole, we would need to compress all of that massive scale down into the size of 3 kilometers. For the Earth, this size would be 9 millimeters, and for our moon, the size would be 0.1 millimeters to get a black hole. On the other end of this extreme spectrum, the most heaviest massive black holes can be up to the mass of 17 billion times our own solar mass, so 17 billion times the mass of our own sun. Just try and comprehend that number. Black holes get their mass by devouring stars and planets and gas and any matter in the universe. A common misconception is that black holes work kind of like a vacuum cleaner, when in fact the gravity of a black hole works exactly in the same like any other gravitational field in the universe. So if our sun was replaced by a black hole with exactly the same mass, then all of the planets and anything else would orbit in exactly the same way. However, it would get really cold and really dark quite quickly. So this feeling that black holes do on stars and planets can sometimes be really violent, having entire stars pulled apart or swallowed whole. But not all of the matter is immediately taken by the black hole. A lot of that matter creates a kind of disk around the black hole, and this is called the accretion disk. Superheated mass of particles that is heated by the friction of the gravity of the black hole. It is now known that at the center of every massive galaxy there is a supermassive black hole in the center as the core or the heart of the galaxy. One of the biggest black holes that we know of is called FSR Cube Blazar, and this is a truly monster, gigantic, supermassive black hole. This incomprehensible monster is 10,000 times the mass of our own supermassive black hole that's at the center of our own galaxy, equivalent of about 40 billion solar masses. Its entire length is about 230 billion kilometers, or in other words, 37 times the diameter of Pluto's orbit. So surprisingly, if you were to fall inside a black hole, you would survive a lot longer in a bigger black hole than a small black hole, and this is because of difference in gravity and scale. If you were to fall into a small black hole with your feet first, the difference of gravity between your feet and your head would be so large that your body would be literally ripped apart piece by piece, eventually molecule by molecule and atom by atom, until you would just be a stream of atoms going into the center of the black hole. But if you were to fall into an average or supermassive black hole, you could spend time there comfortably for weeks or even longer. One of the greatest places of mystery and amazement with black holes is the event horizon, the edge of the actual black hole, and this is the point of no return. It's not the kind of a metaphor or a funny way of saying that the gravity is really large. It literally is the point of no return. Beyond this point, the event horizon, nothing that passes it could ever come out again. So to understand better the strangeness of black holes, let's think about the thought experiment. And we have 2 people in this thought experiment. We have Alice and Bob. Alice will be falling into the black hole, and Bob will be in a safe distance away looking at Alice falling in, and we'll see what happens. So from Alice's point of view, Alice gets closer and closer to the black hole and she passes the event horizon. But from Alice's point of view, she cannot even tell the difference. She doesn't feel any different and she doesn't know know in any way that she's past the event horizon. So for her, she just falls through, and now she's inside the black hole, and she has no idea that she's in the black hole. In Bob's point of view, Bob looks at Alice falling towards the black hole, and as Alice gets closer and closer to the event horizon, Alice appears to be moving slower and slower and slower until she eventually becomes still at the event horizon, and the light coming from Alice starts getting stretched and stretched, and this causes the redshift of the light. So in Bob's perspective, Alice kind of burns up near the event horizon. She never passes the event horizon in Bob's point of view. So Alice falls perfectly well through the event horizon, nothing strange happens, but Bob sees a completely different thing. Bob sees Alice getting slower and slower and stopping at the event horizon and kind of burning up near the event horizon. Now, the strangest thing here is that both points of view are correct. Both ways of looking at this are correct. Alice is correct and Bob is correct. They're equally correct. Now, this is the strange kind of result that you get when you mix quantum mechanics with general relativity, the physics of really small and physics of really big and massive objects. It's truly strange. One of the reasons why this is allowed to happen is that once Alice passes the event horizon, the inside of a black hole past the event horizon is actually not a part of our universe anymore. Past the event horizon, the inside of a black hole is not considered a part of our universe anymore. In time or space, it is a completely different thing. So arguably even a stranger effect that happens is when Alice actually passes the event horizon. Now, when she passes the event horizon, time and space literally switch places for her. For every second that Alice spends inside the black hole, she gets only closer to the center of the black hole, the singularity, where the entire mass of the black hole is concentrated in. This point is believed to be with infinite density. So quite literally, the only possible future for Alice or anything else passing the event horizon, the only possible future is actually at the center of the black hole, at the singularity. Saying that you're going to escape the singularity is like saying that you will walk away from tomorrow. It's literally impossible. In a similar way, if Alice had a rocket and she accelerates out from the black hole, the only thing that happens is that Alice gets closer to the center of the black hole. So even if she struggles, aims her rockets at the opposite direction from the center of the black hole, right out from the black hole, accelerates even at the speed of light, she will only get closer to the center of the black hole, the singularity. And this is truly profoundly strange. Another interesting thing that I forgot to mention is that near the event horizon there is actually an interesting orbit where light itself can circle around black holes. So it's possible to be in some kind of position near a black hole where you're looking in front of you and you can see your own the back of your head, because light can circle around the black hole and come to you. It's really bizarre, and these are just such weird mind-bending objects. I believe our minds aren't just equipped to handle this kind of weirdness. It's just like all these words that I've said in this video, like, could you truly understand them? I'm not sure I understand them. It's just such a weird thing to think about, and that's why I love black holes, and they're incredibly wonderful with what they do with light. I hope I find some good illustrations for this video. And if you heard physicists or astrophysicists talk about that all our laws of physics break down at the center of the black hole, this is exactly because all the equations show that in the center there is a singularity with infinite density, and physicists don't really like the idea of infinities because there is this idea that there can't really be infinities in nature, so that's why it's said that the laws break down. What we need to understand black holes, what happens at the actual singularity, is a unification of the theory of general relativity, the study of the really big, massive and gravitational objects, and the quantum physics, the quantum theory of gravity, what happens on a really small scale and what happens with gravity on a really small scale. We need a new theory. Currently what we have is not adequate enough for us to understand the true nature of black holes, but we're doing quite a great job at it. So I hope there were some interesting ideas in this video, fascinating to think about. If you have any ideas, please leave them in the comments. Thank you so much for watching, and take care.